Okay, so we're looking at an extension of the previous video, and these are ones that are called the double angle formula. And from the previous video, we've got some of our formulas here, and we're just going to use the plus variation. And you've already got these down. But what we're looking at is what happens if the second letter is the same as the first letter. Okay, so we end up with two of the same. Okay, so what we've got is sine A plus A. Now, obviously, sine A plus A, I'll just change colours, is sine of 2A. But then you've got the same number here, sine, cos, cos, sine, they're both the same numbers. So end up with 2 sine A, cos A. And that's the first of our double angle formulas. Okay, so that's one that you would write down. Okay, now with cos, okay, we've got cos 2A, obviously. And down here we're going to have tan 2A, so we'll get that started. So we end up with cos A minus sine A, and cos times cos is called cos squared minus sine squared. Okay, and that's the first of 3 different formulas for the cos 2A. From previous work, we know that sine squared plus cos squared equals 1, or sine squared equals 1 minus cos squared, or cos squared equals 1 minus sine squared. So we know that from our Pythagorean relationships before. So if I replace cos squared by 1 minus sine squared, so instead of having 1 minus sine squared, in cos squared I have 1 minus sine squared, end up with 1 minus sine squared, which is the same as 1 minus 2 sine squared. So that's the second formula. And the last one, instead of having sine squared, I replace it with 1 minus cos squared. So I end up with cos squared minus 1 minus cos squared. We end up with 2 minuses. And so the third variation, which is the same formula for cos 2A, is 2 cos A minus 1. So cos 2A has 3 variations, and they all work. Whereas the last one, tan 2A, is just going to be 2 tan A over 1 minus tan squared A, and there's only one for that one. Okay, so cos is the more flexible one. Okay, copy those and come across. Okay, so we've got tan alpha equals whatever that angle equals. We have to find sine, cos, and tan of 2 alpha. Now we know that sine 2 alpha equals 2 sine cos, and cos has 3, so it doesn't matter which one we use. So I'll just use cos squared minus sine squared, and tan only has the 1. Tan squared. Now, in the last one, we need tan alpha, and we've got tan alpha. So the last one we can actually do straight away. So tan 2 alpha equals 2 times 4/3 over 1 minus 4/3 squared. So we have 8/3 over 1 minus 16/9. 8/3 over minus 7/9. 8/3 times minus 9/7. 3 and the 9 goes 3. 3 8 to 24. So we end up with this. Now the thing I forgot to say is that we'll just say that these are all in the first quadrant. Alpha's in the first quadrant because tan has another answer in the third quadrant, which is also positive. Now, to get these other guys, we need to have sine and cos, and we don't have sine and cos, but we could draw a triangle. So there's alpha in an angle, and there's a right angle there. So tan is opposite over adjacent, and then using Pythagoras we get 5 for the missing side. So we know that sine alpha is 4/5 and cos alpha equals 3/5, just normal ratios. So sine 2 alpha equals 2 times 4/5 times 3/5. 2 4s are 8, 3s are 24 over 25, and that one's done. And cos 2 alpha equals cos squared. So 3/5 squared minus 4/5 squared, 9, 16, which gives us minus 7. Okay, so with these sort of ones, you need to draw a triangle and then use the relationships that we know. Okay, come across when you're ready. Okay, so we need to use what we've been using, and we've got to only end up with sine 2 theta. We can't have anything else. So the first step is we can break 3 theta into 2 theta plus theta, and that's going to be the same number. And then we've got sine 2 theta cos theta plus cos 2 theta sine theta. So we've still got problems, big problems. We can't have any causes, and that 2 theta is no good. So the only thing that's good so far is that last part there. Okay, so now we look at sine 2 theta as 2 sine theta cos theta, and then we've got another cos theta from that one. And then cos 2 theta has 3 variations, but I only want the one that's got sine theta. So I'm going to use 1 minus sine squared theta and sine theta. So now I've got sine theta, sine theta, sine theta, and I've just got to get rid of those two. Okay, so I've got 2 sine theta. Now this is cos squared again, which means I've got 1 minus sine squared again, plus 1 minus sine squared sine. Now it's expand out. 2 sine theta times 1. 2 times minus is minus 2 sine cubed, plus 1 times sine theta, minus times a plus is a minus, sine squared times sine is sine cubed. And then just group terms. 2 plus 1 is 3, minus 2 minus 1 is minus 3. And so now all my answers have sine theta and QED. So that's, I've got, oh, not QED, but I've actually finished it. So with these sort of questions, you've just got to keep manipulating until you just get what you need. Okay, and they've all been worked out before. Okay, let's move, got one more to go. Okay, so these questions here, they obviously can't be simplified, otherwise you wouldn't be asked to do it. And so we've just got to try to work out a way of making it look tidier. Okay, so the only thing we can do with the top is we know that it equals 2 sine A cos A. That's the only thing I know for that one. Now, on the denominator, I've got cos 2A, and I've got 3 variations. But what I'm going to do is I'm going to try to use one that gets rid of the 1, because that's the odd number. So I've got 1 plus. Now, one of the variations for cos 2 theta is going to be cos squared A minus 1. And that's the one I'm going to pick, because then the 1s are going to cancel out. So you end up with 2 sine A cos A. The 2 1s cancel out, so you end up with cos squared A. And then you think, well, what can I do to simplify things? So I can do that cos kills one of them. So I end up with 2 sine over a single cos. And then it's getting pretty close. Then we just say, well, what's sine over cos the same as? And that's the same as tan. So we've simplified a fraction down to something simpler. So again, all these sort of ones can be simplified, just a matter of manipulating and working your way through. Okay, thanks. See you later.